edition of Coffee and Containers. This is a regular series to discuss various aspects of platform engineering, infrastructure as code, containers, Kubernetes, and more, with the goal really of building a tight community of professionals motivated to collaborate and share ideas and best practices, all in the time it takes to drink a cup of coffee. I've got my, actually my Shipa container filled with coffee here today. So thank you, Shipa, for sending this out to me. And I will be done with this before this event is over for sure. If you enjoy this content, I really encourage all of you to subscribe to the channel here to stay updated with all of our regular content. We're adding stuff kind of on the pace of about one a week right now. I'm Jim Shilts. I'm the founder and president of North American DevOps Group, and I'm also a developer advocate at Shipa, and I'm going to be the host and moderator here for this discussion today. Today, we're going to do a mini panel again with two great thought leaders. We have Bruno Andrade, who's the founder and CEO of Shipa, and we have Alex Chircop, who's the founder and CEO of StorageOS. So we've got two big guns out here today. I hope that they are nice to me, just the lowly developer advocate on the call. For today's discussion, we're going to talk about simplifying storage in Kubernetes, which really seems to be a big challenge for a lot of people that we talk to. So excited to get into this conversation. But before we do jump into the conversation, I'd like to have Bruno and Alex both just quickly introduce themselves. So Bruno, if you want to say hi to everybody and just tell us a little bit about you before we get started.
Yeah, no, hey Jim, great to be here. As a little bit of a background, I've been around the I would say cloud native space for some time. Previously focused more on the infrastructure space, and then transitioning over more to the application as we've noticed this as being a problem. But as a background, I'm a sysadmin, right? At heart, I'm a software engineer and a sysadmin before we had the fancy names of SRE, DevOps, and platform engineering. So I had the opportunity to kind of start back then when we didn't have those all those fancy titles. Yeah, that's me.
Cool. Thank you, Bruno. And Alex, would you like to say hi to everybody?
Hi everyone, and thanks Jim for having me on this session. It's really great to be here. So my name is Alex Chircop. I'm the CEO and one of the founders of StorageOS. Similar to Bruno, my sort of career started back in the days of sysadmins and kind of like progressed into infrastructure engineering, working for some large financial services until the startup bug got me and we created StorageOS. I also have another hat because I'm also the co-chair of the CNCF SIG storage. So I think I'm sort of very lucky to be part of this new growing cloud native community.
Cool. Thank you very much, Alex, and thank you again, both of you, for participating here today. So let's now talk about simplifying storage in Kubernetes. So when we think about storage, it's most likely not the first thing people consider when they're starting down their Kubernetes or their cloud native path. But it can really be a very complicated topic, not just as you get started, but definitely more so as you scale. So I'll ask this first question. Maybe you can start with the first response, Alex, then Bruno, you can give your 2 cents as well. But are there strategies to simplify deploying to and operating stateful applications within Kubernetes?
Yeah, that's a very common question, and you know, one of the first things that I'm going to put out there, despite this maybe being controversial, is that all applications are stateful in some form, in the sense that all applications need to store state somewhere, whether it's in a database or a message queue or just files or an object store, for example. And the reality is, you know, what we see as organizations and developers grow into this new orchestrated and cloud native space, we kind of see this advent where applications are put into containers, and this makes the applications portable. And as soon as applications became portable, we see organizations looking at orchestration, and obviously, you know, Kubernetes being the leading orchestrator there. Now, the key thing about an orchestrator is it automates the infrastructure. So now a developer can compose and have a declarative application, so they can specify what containers their application needs, but also, you know, their compute, their networking requirements, etc. And the challenge has always been, what do you need to do when it comes to storage? So what we're doing with StorageOS is providing that cloud native storage environment to provide developers that declarative and composable way of defining their storage, defining the attributes that their storage needs. And there are a handful of principles here that you know, people should look out for when considering cloud native storage. So the first most important item is the concept of having storage that's application centric. And what do I mean by that? Well, in the traditional storage world, storage is typically presented to a server or an operating system instance. But of course, that's no longer the unit of work in an orchestrated world. In an orchestrated world, the unit of work is the application running in a container. So what you really want is you want your storage to be portable, to be focused on the app and be able to follow the app as it moves within and scales within a cluster. The second item that is really important is that after developers have made that investment into containers and made their application portable, you also want to consider providing storage services as software, because that allows you to also be platform agnostic and to be able to use different cloud providers or different on-prem solutions. So this effectively allows you to allows developers to take the advantages of that declarative and composable environment everywhere. And then finally, the last thing I'd like to say is you want to look for storage solutions that are agile. And I know that's terribly cliched, so I'm kind of opening myself up for another set of questions there. But what I mean by that is this: in cloud native environments, in orchestrated environments, the clusters are just more dynamic. Nodes come and go. The developers scale up and scale down clusters on the fly. And what you're really looking for, therefore, by this agile environment is the ability to provide that deterministic performance and the security and the availability, despite all of the changes that are happening under the covers. And so that's how I would kind of summarize this, in that you look for a software-based platform agnostic storage solution that can integrate natively with your orchestrator, and that enables the developers to have a templatable declarative storage interface, which allows them to build anything as a service.
Cool. Thank you, Alex. Bruno, any follow-up to that?
No, I very much agree with Alex, and I think as a big part of what he said is that dynamic part of the storage bringing over to the developer, right? I think one thing that transitioned a lot from my time as a sysadmin, at least from a personal perspective, is that now everything is very driven from a developer perspective, right? So we had that time where we were creating VMs or physical servers, but then VMs, and then we were trying to automate things with Puppet and Chef and Ansible and environment. Developers, they would wait for 2 or 3 days or a week to get their environments ready and available. But now with containers and cloud computing, everything became so dynamic. And one of the challenges that we saw on that part, it was the storage following up, right? Because a lot of the technologies out there, they try to bring the same sysadmin storage concept to Kubernetes, and that becomes really tricky, right? For you to follow up the speed that you need to actually to spin up workloads, create volumes, attach it to it, delete when you don't need anymore. So it changed the mentality, but some of the folks, they still kind of thinking about storage on an old way. And from a developer perspective, they face a challenge. What we see a lot of there is that they face a challenge that they're getting dragged into the infrastructure layer level now, because Kubernetes is great as a tool, but it blurred the line between the developer and the operator in a way that your developer, they have to learn what is a PV, what is a PVC, what are the modes that you have to enable. So it blurred the line and brought complexity. So I think there is big win for software technologies like StorageOS and the approach that Alex mentioned, for example, where we bring that approach more from a developer perspective in a way that we facilitate as much as possible from a consumption perspective, that they can easily create, bind, and destroy as they need from a workload perspective. And I think the more we focusing on the application rather than the infrastructure itself, I think the more of a win we can give to the developers as well.
That's exactly right. The benefits of having the declarative format that applies to every layer of the infrastructure, whether it's compute, network, or storage, effectively means that now the developer is in control of the attributes for their application, and it means that they can deploy their application in exactly the same way, whether they're developing on a laptop or deploying onto bare metal servers or cloud servers or VMs. It's kind of all the same. They get the same homogeneous experience.
Yeah, and I think another part of it as well is because Kubernetes was so complex in the beginning, a lot of the folks focused on the cluster management piece, right? So how do we spin up and how do we upgrade clusters? And now we're seeing the evolution of that with the managed versions or even the on-premises version from past perspective that are launching that can, or Rancher, for example, that helps you manage these clusters. But as organizations, they get their feet wet on Kubernetes and now they understand how to use it. They are bringing out their stateful applications to that. Now, the problem is, at least in my opinion, is moving away from the cluster management. Of course, there will always be opportunities for cluster management improvement and so on, but it's moving away more and more from a cluster perspective and moving into the app. Now that we're getting a larger number of apps being deployed and consuming more complex scenarios, now how do we actually focus on that and bringing that experience at the application level rather than let's build another solution for a cluster perspective, right?
That's exactly true. And dare I say it, Kubernetes is finally becoming simple enough to be boring. So, developers can consume Kubernetes easily through managed services or one of the available things, and it's now more important to focus on the application experience rather than the cluster management.
I agree, and I know a lot of people, they don't like me when I say that, but I very much agree with the terminology that Kubernetes should disappear, right? It's a great application, it's a great tool, it's a great platform, but if you can focus more on the application perspective, the more you have to win and the more speed you gain. And some people get really fixated on the complexity of the cluster itself, and it's cool. I'm an engineer. I like to deal with that as well. But business, they run on the applications that you provide to your user, right? So the faster you can get these applications out and updated, the faster your business moves. So that's I think that's a great way things are moving.
Could agree more.
I've heard somebody compare Kubernetes to a souped up assembly line. If you think of it like that, it's not the tool, right? It's the means to getting the real tools and solutions built. So let's try to make this a little less boring, I guess, right? We don't want Kubernetes to be all that boring, but let's talk about scale. Because frankly, doing a lot of these really cool things that we talk about all the time looks really great in like a demo environment or a sandbox environment, but people really aren't going to get any value from a lot of this stuff unless they start scaling and they start bringing lots of different applications and projects into the mix. So if we talk about deploying stateful applications at scale, Alex, is there anything you can show or talk to in regards to how StorageOS would support that?
Yeah, I'll show you a demo in a second, but I wanted to talk about some of the things that allow applications to scale, and then I'll show you a really simple way of providing this declarative interface to allow applications to create, developers to create applications that use storage on the fly. I think one of the big aspects, coming back to that agile storage concept, is that we see developers and we see these orchestrated solutions enabling workloads that simply weren't possible before, right? So we see the simple fact that you can template an application means that you can build services really easy. So we have some of our customers, for example, building database as a service or building CI/CD as a service, simply because they can just spin up environments on demand. And therefore, what we're looking to do when we talk about scale within a storage system, there are two aspects to this. There's the scale of the data plane, and that talks, and that is a more traditional speeds and feeds kind of discussion where we're talking about IOPS and megabytes per second, etc. But then there's also the speed of the control plane, and this is really important, right? Because in that Kubernetes environment, apart from the dynamic structure of the cluster in terms of nodes scaling, you also have the concept of volumes coming and going much more dynamically. So we have end use cases where enterprises are creating literally tens of thousands of volumes and deleting them every single day as part of a CI/CD process, and that's something that needs to storage systems need to kind of adapt. And StorageOS is one of those solutions providing this disaggregated consensus concept in the control plane, where every single volume effectively has its own mini brain and can manage placement decisions and failover decisions independently. So you don't get a serialization, and this allows lots of activity to happen at the same time, but it also means that volumes can transparently migrate between different servers within milliseconds, and all of these operations are measured in milliseconds, which is fairly game changing, because it enables more advanced use cases than what developers could do in those traditional environments. So what I'll do is I'm going to show you. I'm just going to share my screen. And I'm just going to show a little demo, which by the way, you can run yourself in an environment using play.storageos.com. So what I have here is I have a simple 3 nodes cluster. StorageOS is actually deployed itself as a container. So one of the beauty of StorageOS is that we kind of follow that platform agnostic and application centric principle to the way the system is deployed. And what we do is we virtualize the storage that's available on each of the nodes within a cluster to create a storage pool that you can then use for dynamic provisioning. So in Kubernetes, you have the concept of a storage class. So what I'm going to show now is we have one storage class defined in this cluster. It happens to be called fast because, hey, we're fast. And the storage class is actually a really simple definition. It's simply a way for Kubernetes to abstract its connectivity to a storage subsystem using CSI, which is the cluster. Sorry, excuse me, that's terrible faux pas. It's the container storage interface, similar to the CRI or the CNI, which applies to runtime and networking, respectively. CSI is a standardized interface that allows Kubernetes to make requests for volumes and to attach and mount volumes dynamically based on the application requirements. And in this case, the CSI for StorageOS is just pointing to the CSI controller. So we'll move on to the demo, and what we'll do is we'll create a PVC. So what's a PVC? A PVC is a persistent volume claim. So this is a way of giving a name to a volume. So what does a PVC definition look like? It's actually very simple. we create, we give a volume a name. In this case, we're calling it a MySQL PVC. We define certain attributes like the number of replicas and the size of the volume. And we define that which storage class that PVC should be created with. So in this case, it's creating the PVC based on the fast storage class that we talked about in the previous instance. We can then create a MySQL instance, which again is a really simple piece of YAML where we say oops. Which is effectively saying I want to be able to run a MySQL container, and I want to have a volume that is called MySQL data that gets mounted in a particular path, and it references the persistent volume claim that we just created. So now that we've run this these two pieces of YAML, one to create a PVC and one to create a MySQL instance, we can just quickly look to see, yes, StorageOS has dynamically created that volume. It's also dynamically created the PVC, as we see there. And if we look at the pods, we see that MySQL is up and running and is happily waiting to take your database workloads. So what we'll do here is we'll create, just to show you that this is actually, you know, a running system, we'll create a little database called shop. We'll create a table for your fruit and populate that table and show that we can actually query the table to show that the data is actually in there. So what I'm going to do next is I just want to show you the dynamism. So today, right now, we have we're going to look at where the primary data for a volume is, and we're also going to look at where MySQL is running. So in this case, we can see that the volume data is actually contained on node 1, and the MySQL happens to be running on node 1 too. What we're going to do is we're just going to coordinate. We're going to coordinate that node, delete the working MySQL instance, which will effectively remove the running pods, and then we're going to restart MySQL. Now, what we'll see is we'll see Kubernetes happily restarting MySQL on another node, node 2 now. This is just pulling down the MySQL container, and it'll be ready in an instant. And here we go. Everything's back up. Everything is back up and running. And what we can do is to make sure that the stateful data for this application, MySQL, is actually still there. We're just going to quickly run a query on the running MySQL instance, and we can see that the table with the fruit inventory that we created before is right there. So that's a really it's a very simplistic demo, but it shows you some of the ease of use of sort of creating stateful services and being able to scale them. You know, you can use that YAML to create 100 MySQL instances in a few seconds, right? And this is the great thing. Whether you're testing or you're doing, you know, pre-prod environments, or you're having multiple environments where multiple developers working concurrently, or another particularly common use case is where people take copies of production data and they just want to spin up a session for debugging a production issue, for example. You can now create all of your environments on the fly with a really simple templatable model.
That's interesting. And one question I have is, MySQL and the databases are a perfect fit. Have you seen other type of stateful applications, or folks moving other type of stateful applications to Kubernetes these days?
Absolutely. So we see a wide variety of stateful workloads move into Kubernetes. And they're kind of bucketed into a number of groups. The first is obviously databases. Most applications have some sort of database on the back end. But there are different classes, there are different classes of databases. So there are some of the more traditional SQL databases where you might have a single instance, or you might have a a primary replica instance. But you might also have uh, some of the newer NoSQL type databases, like Cassandra or MongoDB, for example, where you have a distributed environment, and in that case, the storage paradigm is slightly different, because you're also trying to provide locality and affinity and working with Kubernetes to make sure that data and applications are co-located. The other big use case that we see quite a lot is message queues. So message queues are a very, very common pattern in microservices environments, as different applications use the message bus to talk to each other. Those message buses tends to require a low latency store, where they can store work in progress, and then they can store the messages in a queue. And then finally, we also see a lot of use cases that concern infrastructure and analytic related components. So I'm talking about things like Kafka and Elasticsearch and Prometheus, for example, which form the core of most infrastructure services and cluster services. And there are some also oddball use cases. So, for example, using projects like KubeVirt, we have customers who are using the KubeVirts to actually spin up VMs as a stateful workload, and have those VMs just be able to migrate within different nodes in a cluster. And sometimes that's because the app hasn't been containerized yet, and sometimes it can be because we're working with service providers who are providing infrastructure as a service to their end users too.
It makes sense, and one question I wanted to ask from a curiosity perspective is, from a few years back, when you started talking about moving persistent applications over to Kubernetes, folks they got concerned because they were understanding how Kubernetes actually worked. So you saw a lot of myths and fears already there. So do you still see some of kind of the common fears and concerns on folks moving that they shouldn't actually be there because this has been solved in a good way?
Yes, sometimes that is a very common question. It does come up quite a bit. I think there are two aspects at play here. The first is that the innovation is happening more and more in the developer workspace, right? And for the longest time, developers didn't really have much of a say in the storage space. Some infrastructure team might provision some storage for them, and they would just have to use whatever was available. But in the new environment, developers are now learning about what they need out of their storage in terms of availability and failover capabilities, and performance and throughput and scalability and consistency, for example. And they're choosing storage systems themselves based on the attributes that their application needs, rather than just some preordained out of the box solution. And I think the second thing is that all applications need to store state somewhere, right? There's unless you're doing some random compute intensive Bitcoin mining or something, you're going to store data somewhere, and therefore what people started with was this concept where maybe they'd run microservices within Kubernetes and have databases or message queues that were running outside of the Kubernetes environment. But once they see all of the benefits of being able to abstract the infrastructure and all of the benefits that Kubernetes gives them for their application, the most obvious question then is, well, why can't I do that with my stateful workloads too? Because just as you mentioned, I mean, I was going to comment when you mentioned earlier that in traditional environments it might take days or a long time to get access to storage. You know, in my experience, I've seen storage provisioning take 6 months sometimes, right? And just because, you know, if it physically requires a disk to be plugged in or things to be cabled up. And so the big advantage here is that developers can now dynamically provision on demand. And this is game changing because it makes everything self-service. They don't have to rely on other people to provision infrastructure for them. And this kind of takes me back to one of the other principles that we kind of, you know, see a lot, which is cloud is not a place. Cloud is a way of doing business, right? It's a case of we end users want to see the on-off consumption model. They want to see the self-service provisioning. They want to be able to have automation on their deployments. And Kubernetes gives them that, whichever environments they're working in.
I agree. Yeah, and yeah, I completely agree, especially with really leveraging cloud for what it's best. You run away from those scenarios that you had to plan the storage really well ahead of the project, and you would go to your data center, see if you have capacity, and if not, you would have to order another big brick of storage that would take months to come over. Yeah, no, I definitely agree. Very exciting days from an application perspective.
Definitely.
Cool. Thank you guys for all the insight there. I'd like to move on to our final problem area here, which is to talk about portability. So really, when we talk to teams, that's really one of the big challenges that despite really the promise of Kubernetes, it's portability is one of those things that's still really, really difficult, whether you're going across prem, the different instances, or across multiple clouds, or a combination, some kind of hybrid environments. That can be extremely challenging. So Bruno, I'm gonna put this one to you. Is there anything that you can talk to or show regarding portability in Kubernetes that might help some of our viewers here?
Yeah, sure. Let me try to share my screen. I assume the screen is visible at this point.
We got it.
So
it is.
That is a good, yeah, we're interesting days as well with the whole kind of Zoom and screen sharing across so many different platforms. I joke around saying that my next startup is going to be a conference software abstraction tool, so everyone can use only one instead of all the others individually. That's an idea for whoever wants to start a startup. I think that might be a good one.
I'll invest.
There you go. So from it is true. One thing that we see from talking to many customers out there is that folks are not these days. They're not consuming one single cluster or one single environment. Again, I think as people get more and more comfortable with Kubernetes and cloud native apps and microservices, one tendency that we're seeing is they're scaling across multiple clusters, and these multiple clusters, they may be on premises, or they may be across maybe a cloud provider or across even different cloud providers. And we've seen the utilization of that in different ways, either the same team using different clusters for different reasons, maybe functionality or locality, or just balancing cloud providers. And we see different or the same or different teams using that. But one of the things that we still see a lot is as you change cloud providers or you change cluster versions and so on, sometimes it brings the complexity of how can we make it easier from a developer perspective that the experience is seamless, right? In a way that if I'm using a StorageOS on GKE, maybe on 5 different clusters on GKE, or maybe if I'm using StorageOS on a GKE cluster and an EKS cluster, for example, how do my developers, they actually develop exactly the same way? They're not concerned on learning the difference from an API version. What am I using underneath? So how do we bring it up in level that developers, they're not concerned about? It doesn't really matter where they're deploying their applications. And that's where we try to come in with Shipa from a visibility perspective, in a way that the way we try to build it is Shipa creates something that we call volume plans, right? And volume plans, they are directly attached to your storage class, the ones that Alex mentioned and showed before. In the case fast, which by the way, it's an interesting name. Every time I look at it, it's nice because everyone goes for the standard or anything. So it's a cool name. So you creating a volume plan from a Shipa perspective, you can, I have one created here, but you can create another one called StorageOS plan 1, for example, and you tie it up to your storage class. When installing StorageOS, for example, across the different clusters, you're going to see that basically the storage class is replicated across the different clusters. So the same volume plan that you're using on Shipa is not directly tied to GKE cluster 1 or GKE cluster 2 or EKS, for example, but it's actually a higher level integration with the StorageOS in this case. Once you create the volume plan and attach to the fast storage class, what you are going to be doing, either as a platform engineer, or if you want to give access directly to your developer, they can provision the volumes using the storage class that the volume plan is tied to. They can quickly come here, they can provision that either from the CLI, they can provision from the dashboard, or they can call the APIs directly and provision that directly from their CI pipeline or their code deployment. But it's as easy as just placing a name, for example. I'll say StorageOS volume 3. You're going to put the size that you want. You're going to define the teams that can have access to this volume. So if you have multiple teams that you have access within Shipa, you can choose which team is going to be tied to this volume, and the pools, right? So Shipa manages everything from a pool perspective. So many pools, you can have different pools attached to the same cluster, or you can have one pool per cluster. But you can choose, for example, I have my GKE StorageOS, and I want to tie this volume to this. What it means is Shipa will connect to the fast volume plan and storage class, and will create the volume in the cluster where this pool is tied, in my case, a GKE StorageOS cluster. And you can choose the access mode based on the version that you're running and the capability, and actually from a functionality perspective that you need. That's it. Me as a developer, I'm not really concerned at this point, how do I do PVC across GKE and the different clusters and so on and so forth. And I have my application already deployed here in this scenario. The only thing I have to do is I can bind the volume to my application directly from here, which again can be done from a CLI perspective, from an API call, and from a dashboard. But if I want, I can just come say StorageOS. You can say if the application requires a restart, which usually it does, and the mount point where you want to make that volume available. So your MySQL database, Postgres, or other apps that you have deployed, they can consume that. Once you hit bind, basically Shipa will start the operation of binding the volume and will make the volume available to the application. Again, this is how we see from a developer perspective, in a way that you're really concerned about how to consume the volumes and the storage, not really related to from a cluster perspective, but really from my application. And if I want to create another volume here, for example, volume 4, the pool may be tied to, let's say, another AKS or EKS, as long as I have my StorageOS installed in there with my fast storage class. Shipa will automatically go in, create the volumes, and bind to your application. Doesn't really matter the cluster that you're using, but now you're focusing more on the application and the storage consumption. Does that make sense?
Very much so. I think it makes it very easy for developers to consume the storage and to build their applications in each of these different environments. I'd like to ask you a question on that, actually.
Yeah.
Do you see developers use this to deploy different applications into different production instances, or do you also see them using this to maintain the same type of application, or the same definition for their dev and maybe test environments, as well as their production environments?
Right now, we're seeing a lot in terms of keeping consistency across different environments, because if you have clusters across, what we see a lot is clusters for development and production, for example, clusters, and having StorageOS with the same class across both clusters and a Shipa volume plan on top, you can actually move your application. You can deploy your applications on cluster dev, and then you can deploy your applications on cluster production. And from a developer perspective, nothing really changes. You deploy exactly the same thing and your application is ready and running. Another thing as well is if you start moving applications around, you have Shipa app move, which allows you basically to move your applications around either within the same cluster or within different clusters. And if you have these volumes present, then it makes it a lot easier for developers as well to keep that portability.
That's a fantastic functionality, because I think, you know, more and more what we're seeing is that the I guess the unit of compute becomes the cluster, and we're seeing organizations deploy a larger number of smaller clusters in many cases, where, you know, rather than just sort of one or two mega clusters, we're kind of seeing hundreds of smaller clusters based on projects or failure domains or business units, for example. And this sort of functionality would be extremely useful as they manage and migrate their applications between those clusters.
Another scenario that we're seeing as well is cluster upgrades. We're talking to a customer, a large customer, where they got tired of kind of upgrading Kubernetes. And so they changed the strategy in a way that when they want to move to a new version, they basically create a new cluster and they move the data from one cluster to the other. And then they just move the applications from one cluster to the other, and they drop the other cluster instead of running upgrades. That is one scenario that it definitely helps in that way as well. So as you move data, then moving the applications become really easy in that sense.
Right. That's you know, it's an interesting pattern. I think using having an orchestrator act as a level of infrastructure abstraction means that the devices can effectively become, you know, we have this concept of cattle versus pets, right? Where the you know the nodes and the compute units no longer have special properties. They're consumed as cattle, so to speak. They're no longer watered and fed as individual pets. The side effect of that is it enables interesting options for you know, upgrades, but also security. So for example, we are aware of a number of customers who are now regularly rebuilding clusters just to keep on top of security issues, or to keep on top of security updates. So rather than you know, apply security patches, which is much more complex when in these sort of cattle scenarios, you just rebuild the clusters and rebuild the nodes, and some of them are doing it as regularly as every 2 weeks. So yeah, having that persistence of data and having that template that you can then just apply means that, you know, even in a worst case scenario, you can just recreate it from scratch.
Exactly. And I think that I agree, and I think that's where the trend is actually going, because everything is becoming everything is coming together from a developer perspective, right? That you can replicate anything anywhere. I really like the pets versus cattle. I still see some folks out there that they are really they preach it, but they are very attached to their clusters. But I think they say their clusters are cattle, but they actually treat them as pets at the end of the day. But I think as complexity, as you remove a lot of this complexity on really treating these clusters as cattle, that where doesn't really matter, right? If I'm running GKE 117 versus 119 or AKS or AKS, it's all transparent for me. Then it really becomes that cattle mentality that doesn't really matter, and you're really focused about your application and your data moving around doesn't really matter where.
And that's honestly, that is a superpower, right? Because if I think back to my days of standardized of more traditional standards infrastructures, we used to call a server a snowflake, and that's because it was really pretty and uniquely built and almost impossible to recreate, right? And people were so concerned that they'd lose sleep at night if a server blew up and they'd have to rebuild it, because nobody could remember or make it standard again. But effectively, what we've done here with these technologies is we've added abstraction at every layer, and we've made it declarative and composable, and that doesn't apply just to the application, but it applies to every layer in the infrastructure there.
Yeah, and one thing that I know, Jim, I'm taking your time, and I'm really sorry about that. But one of the things that we really want to help people shift the mentality is that as engineers, and I say that because I'm my background, I'm an engineer as well. You want to build really complex things, right? And we're really proud of building complex scripts where if tomorrow we go away, nobody really can maintain that thing. But now with the whole GitOps movement and everything from a developer perspective, I think moving more and more towards focusing on the applications, right? Rather than thinking about clusters, if it's a container, if it's a 117 version versus 116. That as you get more people up, think about the kind of higher part of the stack. I think it's going to be a big win, and it definitely opens a lot of opportunities for application consumption, data consumption, and make things a lot more dynamic each day, I think.
Absolutely. I completely agree with that. It's what people were working towards for almost 2 decades. We've kind of seen this arc with starting with VMware, and then OpenStack and Heroku and AWS, and then Docker, and then finally Kubernetes, and now we have the layers of abstraction that happen on top of that to complete that arc. But this is something that the world has been working on for its better part of 2 decades, and it's so incredibly exciting to be part of this journey as it finally becomes reality.
I agree. I definitely agree.
Cool, guys. Thank you very much. I think we could go on for a little bit longer, but I'm going to need Shipa to send me a bigger cup because I need a refill at this point. But I think this was a huge success. I think we definitely brought the sexy back to storage in Kubernetes, right? That was the goal. Was it that, or was it simplifying storage in Kubernetes? One of the two. I think we did both, right? So
I'm not sure if it was the goal, but it sounds good.
I really appreciate both of you being here and spending your time with us. And for everyone who's watching, if you'd like more details on the topics we covered today, I'm going to be adding some links into the description below the YouTube video, so you can get in touch with Shipa and StorageOS and find out more about the partnership and integration between these two solutions. And with that, guys, thank you very much. It's time for me to get a refill, and we will see everyone else on the next Coffee and Containers. So thank you very much. We'll see you next time.
Thanks, everyone.